We had a change of plan here. I wasn't here at school tomorrow or yesterday. So I added a deltamath assignment for this chapter, which we're going to just spend today working on the deltamath. We'll deal with section 15.3 next time. I have some deltamath due dating to change here, but we're going to be working on deltamath chapter 15, number 0. So this was the added one in is the 0th one. That's why I got a funny number. So there's the problems they're going to be doing is just turning a exponential or table into an exponential function like we've done in the homeworks. Any questions on how to do that?
Just got to substitute those numbers into the equation, right?
Yeah, use the x equals 0 to find the a, and then you use that along with x equals 1 to find the b. So from 2 points, again, this is easy if I have 0 for x. If it's not 0 for x, then it's a little bit more tricky, but we have examples in the homework of doing that. So it says, given the following exponential function, identify whether the change represents growth or decay, and then determine the percent rate of increase or decrease. So to determine if it's growth or decay, I can just kind of look at the b, right? Because that number is between 0 and 1. This is decay. And to find the percentage rate of increase or decrease, I'm basically solving for r in that formula we had last time. So if I did that, r would be like negative 98. Oh, I didn't like that. Oh, probably doesn't need the negative. Yeah. So r was negative 98, but if it's saying percent decrease, we don't need to put negative and decrease. That's silly. A group consisting of 5 aggressive zombies quadruples in size every hour. Which equation matches the number of zombies after 8 hours? So I know that the leading coefficient should be the initial amount, right? I'm just using that p equals p naught times a plus r over 100 to the t. So I know that this one is already gone because the leading term is a 4, not a 5. And I know the time is 8 hours, so can't be the last one because there's no exponent of 8. So I just have to decide whether it should be the second or third one. Which do you think? It is the second one. Okay. So it says the quantity with an initial value of 30 decays exponentially at a rate of 8.5 every 9 weeks. What is the value after 42 days rounded to the nearest hundredth? What does this sound like? Just like the homework from last time, right? You're going to be using your calculator to graph. You don't even need to graph this to solve because it's asking for a quantity, not a time. Right? So you're just going to be plugging that stuff in. What's going to be the tricky part on this one? Dealing with the units, right? What is the rate of exponentiation given in? 9-week intervals. What is the t given in? Days. So I'd have to figure out like how much of 9 weeks is 42 days, and that would be my exponent. Does Is everybody okay with that? 9 times 7 is 63, right? So my exponent would be like 42 out of 63. Or I guess that reduces down to 6 over 9 or 2 over 3. Same kind of idea here. So this is another one, but here the units aren't all goofy on you. Probably should have put this one before the other one. Exponential decay. This is though now asking for a time, right? So you're going to have to make sure you're solving it on your calculator. So you're going to be graphing and finding the intersections. This one is just asking you for the value after 4 years. And there's a depreciation or whatever every 3 years. So it's like a mixed units kind of thing. But again, nothing crazy. This one is another one where you'd have to use your calculator to graph it because it's asking for how long. So you'll be solving for t. So they're just going to be like the homeworks from 15.1 and 15.2. So just some extra practice here. But that's the plan for today. If you get stuck on anything, feel free to come up and talk to me. I'm going to update the schedule on My Notre Dame and the due dates on deltamath to make sure things are actually reflecting the likely due dates that they'll have. But that's it for today. You guys cool? All right. Get crack-a-lackin', my dudes.